So, you're not leaving already?
Yeah, I gotta run it.
Oh, man. Okay, well, watch the video. All right, so we're going to talk about 3.5, which is complex zeros and the fundamental theorem of algebra. Okay, so basically 3.5 is just a continuation of 3.4. The only main difference is we are not limiting ourselves to real numbers anymore. We can use complex numbers or imaginary numbers. So we've kind of hinted at this, but this is the fundamental theorem of algebra. Okay, and it says basically every polynomial of p of x equals a sub n x to the nth plus a sub n x to the n minus 1 plus etc. all the way until you get down to a sub 1x plus a sub 0, where n is greater than or equal to 1 and a sub n cannot equal 0, with complex coefficients has at least one complex zero. Okay? So this works with even if you have complex coefficients or real coefficients. Basically, what it says is whatever your degree is, you're going to have that many of solutions, including complex solutions, if that's the case. Okay? We've also got the complete factorization theorem. And basically what it says is if p of x is a polynomial of degree n greater than or equal to 1, then there exist complex numbers a, c1, c2, etc., all the way until you get to c sub n. A cannot equal 0, obviously, such that you can write the polynomial function as a series of factors a times x minus c1 times x minus c2, etc., until you get to x minus c sub n. Okay? Now we've hinted about that previously, and we're just going to state it as fact now. Okay? Complete factorization theorem says you should be able to factor anything now, any polynomial function. Okay? So let's do an example here. Well, that was a little bit off camera, sorry. Okay? So if I have p of x equals x squared minus 3x squared plus x minus 3, and I'm off camera, thank you. I thought I was on camera. Okay. So now we should be able to factor this. And Michael, what do you think? How do we factor that? Except for that's supposed to be an x cubed.
Oh, okay.
Okay?
Wait, still thinking. Yeah,
Let me make sure I wrote down right. 3x cubed minus 3x squared plus x minus 3. Okay, perfect.
So can you take x cubed minus 3x squared and then take out an x squared?
Okay, we're going to factor an x squared out of the first two terms. We'll be left with
X minus 3.
x minus 3.
And the next one you can take out a 1.
We can take out a 1, and we've left the x minus 3. Okay? And so therefore, we can pull this out, right? We've got x minus 3 times
X squared plus 1.
X squared plus 1. Can you factor that?
Thinking. X
Okay.
plus 1, X minus 1.
Nope.
No, that wouldn't work. We have to use some really complex numbers.
Now, if we were to set each of these to 0, x minus 3 would equal 0, and so that x would equal 3, right? And x squared plus 1 would equal 0, x squared would equal negative 1. And if I take the square root of both sides, I would get
Square root of negative 1, or I.
x would equal plus or minus I, right?
Yeah.
Okay. Now, I would write this as that factor, right? How would I write this as a factor? So I'd have x minus 3,
Or X plus I.
x plus I,
X minus I.
and x minus I. Okay? So you could actually go from here to here, but I just wanted to kind of show you that in between. So if you've got x squared plus 1, you can just go ahead and factor that into x plus I, x minus I. Okay? Does that make sense? All right. Let's do another one. What if I had p of x equals x cubed minus 2x plus 4. Okay? So, what do you think? Must be Nicole's turn. How would you factor this? Any ideas? Say it again. I can't take out an x squared because I don't have an x squared there. I could, but that wouldn't help me. Is that a phone a friend? Okay, why is your phone Cameron?
Could you take out a 2?
Could you take out a 2? You could, but that wouldn't help you. Demi. Find your P's and Q's. That's what we need to find. What are your P's and Q's, Nicole? Plus or minus what? 1, 2, and 4. And your Q's are plus or minus 1, which makes it nice because now I just have to worry about that, right? What do you want to try first? Or do you want me to give you a hint? Why don't we try negative 2? Because I don't want to take too long on this problem, and I looked ahead. Okay? We're going to try negative 2. Because I just wanted to try it. I thought it would work. I'd probably, in real life, I usually start with the 1s, and then I go to 2s. I don't want to take too long, and I appreciate it if you can work. Can you help me do the synthetic division with a negative 2? Rory, can you help me? What are the values I should put here?
1, 0, 2, negative 2, 4.
Negative 2 and 4. Okay, 1 and 0 is 1 times negative 2. 0 minus 2. Negative 2 times negative 2.
Negative 4.
Positive 4. 4 minus 2.
2.
Positive 2. 2 times negative 2.
Negative 4.
Negative 4. And I get a 0. What a lucky guess, right? Okay, so this factor becomes what?
X squared, x plus 2.
That factor becomes x plus 2. And this, as I look here, becomes what?
X squared,
X squared minus
2x.
2x plus 2. Can we factor that, Eunice?
No.
No. So when it's not easily factorable, what's our always works?
Because,
What always works when we factor it, no matter what?
Use your imagination.
Imagination doesn't always work though.
so, no.
What always works, Hallie? How about Nathan?
Okay.
Quadratic formula. Thank you, Nathan. Do you remember what the quadratic formula is? For some of us who don't remember, negative b plus or minus the square root of
U squared minus 4ac
2 squared minus 4ac
over 2a.
over 2a. All right, so now that we got that, Eunice, can you plug in all these numbers in order to factor this?
Is it negative, positive 2?
Positive 2 plus or minus
negative, yeah,
square root of
negative 2 squared
negative 2 squared
minus 4
minus 4 times
1
1 times 2. All over 2 times 1. So this gives me 2 plus or minus 4 minus 8 all over 2, right? Which is 2 plus or minus square root of negative 4 all over 2. What's the square root of negative 4? It's 2i. So 2 plus or minus 2i all over 2. This 2 cancels, and I'm left with 1 plus or minus I. Right? Now, if we want to write this in factored form, how do I write that as a factor? So I've got my x minus 2 still. Am I off the board? Oh, you guys didn't tell me I was off the board. What kind of cameraman are you? X plus 2, thank you. Times, write that as a factor. X minus 1 plus I, and x minus 1 minus I, right? So if I simplify and distribute x plus 2 times x minus 1 minus I, and x minus 1 plus I equals p of x. Does that make sense? You guys feel like factor monsters now? Bring it on. I can take it. Jeffrey, how do you feel?
Come on.
You're starting to turn green into the Hulk, right?
Yeah.
The factor Hulk. Okay? All right. Do you want some more theorems? No? I'm going to give some to you anyway. All right, so you got these all written down. All right. Okay, so this is the Zeroes Theorem. I've mentioned this before, but we're going to make it official today. The Zeroes Theorem says every polynomial of degree n greater than or equal to 1 has exactly n zeros, provided that a zero of multiplicity k is counted k times. Okay? I kind of mentioned that either yesterday or the day before, I can't remember which. But yeah. So we can do another example. P of x equals 3x to the third plus 24. Sorry, 3x to the fifth. I can't read. Plus 24x cubed plus 48x. And so, Andrew, oh, you look like you really want to factor that. How would you do that? Not yet, because I don't have constant there. Just an x? How about 3x? Let's take out the 3x. Okay, if I pull out a 3x, I'm left with x to the fourth plus, you said x squared, what's the coefficient? 7? No, it's 8 actually. 8x squared plus 3 out of 48 is 16. You do that. Okay? All right, so we pulled the x out. Can we factor that? Yes, okay. What are your factors of x to the fourth? X squared and x squared. What are your factors of 16? 4 and 4. And they are plus and plus. Can you factor that? X plus 2x, x minus 2x? No. It would be better if it was a minus 4, right? It would be x plus 2 and x minus 2. So remember, if I set that equal to 0, x squared equals negative 4, right?
Yeah.
And you take the square root of both sides and you would get, what's the square root of negative 4?
Plus 2.
2, no, I, right? So this x squared plus 4 factors into x plus 2i and x minus 2i, right? I still have my 3x out here. And this factors into the exact same thing, right? So that's going to be squared and squared. That's your p of x. Okay? So I've got 2, 4, 5. Just like my Zeroes theorem says, it has exactly n zeros provided you count your multiplicities. So my x, so what are my zeros? X equals 0, x equals 2i, and x equals minus 2i. What are your multiplicities? 1, 2, and 2. That adds up to 5, so I've got a 5th degree polynomial. I've got 5 solutions. That looks like a terrible eye. If I count all of my double zeros. Okay? Make sense? All right, so how about let me give you, oh, we're going to play Jeopardy. You guys like to play Jeopardy?
Yeah.
What's Jeopardy? What's Jeopardy, Allie?
Just a question and
Yeah. Well, how does it work?
they give you the answer and you find the question.
And you guys come up with the question, okay? All right, so here's what I'll do. I'm going to give you the answer. I want you to find polynomial polynomial of degree 4 with zeros at I, negative I, 2, and negative 2. So, Kekana, it must be your turn. If I have 2 as a 0, how do I make that a factor?
Sorry, what was the question?
If I have 2 as a 0, how do I make that a factor? That's what we've been doing all the time, right?
Yeah.
Okay. If I've got x plus 2 over here, what is the 0? It's the opposite, right? So if I have 2 as a 0, what's the opposite? X minus 2, right? If I have negative 2, what's the factor? X plus 2. If I have I as a 0, what is the factor? X minus I. And if I have negative I, x plus I. Okay, so I've got some sort of a polynomial function. Now I just have to FOIL that out. So x minus 2 times x plus 2 is what? X times x is? X squared. Negative 2 plus positive 2 is 2x. 0. Negative 2 times positive 2 is? Negative 2 times positive 2? Negative 4. Okay? Now we're going to do the same thing here. X times x is? X squared. These are going to cancel. What's negative I times positive I? It's negative I squared, right? What does I squared equal? So we're subtracting a negative 1. So therefore this becomes plus 1. So I've just turned an imaginary number into a real number, right? Now I've got x squared minus 4. I'm going to multiply those out, but I won't make you do it. I'll have Daniel do it. You can tag him since he's sitting next to you. So x squared times x squared is x to the 4th. X squared times 1. X squared. Negative 4 times x squared. Negative 4 times 1. Negative 4. And I can combine those two, so I'm going to get p of x equals x to the 4th. Minus 3x squared minus 4. Okay? I gave you the answers. You gave me the question. You like Jeopardy? Who likes Jeopardy? Okay? Can you do this on a test, on a quiz on Monday? Lauren?
Is our test on Thursday?
No, we'll probably do it the next week. Oh, no, wait. Actually, today is Thursday, right? Yeah, we'll do it a week from today. Yeah. All right, the last thing I want to just show you really quickly, and then we'll be done with this section, is what we call the conjugate pairs theorem. Okay? And basically, what the conjugate pairs theorem, basically what it says is, if a polynomial P has real coefficients and if complex number Z is a 0 of P, then the conjugate the complex conjugate, we'll call it Z bar, is also a zero of P. So essentially what that means is anytime you have a complex number, it's always going to come in a pair. Okay? So, if I said to find a third degree polynomial with zeros at 1/2 and 3 minus I. Okay, that's only 2 solutions, right? So if it's a pair, what by default has to be the other 0, Demi? I've got 1, I've got to have a pair with it, right?
What's the same?
It's the conjugate of it. You know what conjugate means? It's the same except for the sign is going to be the opposite.
So
3 plus I. Okay? So these factors would be what? How would I write 1/2 as a factor?
2x minus 1, right?
2x minus 1 or x minus 1/2. And then I'd write this as a factor as just put x minus whatever that is. X minus 3 minus I and x minus 3 plus I. Since we're out of time, I'll let you FOIL that all out. That'll be easy for you, right? Okay. The quiz on Monday will be on 3.1. See you all on Monday.